this video, we'll talk about Java generics. The basic idea of generics in Java is using a type as a parameter to methods, classes, or interfaces. The benefit of this is that the method, class, or interface can be written once and used for any data type. There are two commonly used classes that implement generics. These are ArrayList and HashMap. When we declare an ArrayList or HashMap, we also declare the type of their elements, and in the case of hashmaps, their keys. Let's start with ArrayList. This is part of the Java collection framework. It implements the collection interface. ArrayList is useful for instances when we need to do more complex array manipulation. Normally, we would declare regular static length arrays like this. We have to specify the type of the array elements and its length, either by declaring a number or the list of elements directly. But with ArrayList, we can use the same syntax to instantiate lists of different types, such as here, a list of integers or a list of strings. ArrayList comes with convenient methods for adding a new element either at the end or somewhere in the middle of the list, removing elements by index or value, checking the array size, checking if the array is empty, finding a specific element in the array, and many more. Here I'll demonstrate the usage of ArrayList. ArrayList is part of the java.util package. The type passed to an array list can only be objects, so here I'm using a non-primitive integer. So here I was able to check if the list was empty using isEmpty, and I was also able to check its size before and after the addition of the 5 elements. As you can see here, I was able to insert the numbers 1 to 5. In this next example, I'll use strings instead of integers. Now here, I'll insert to a specific index, instead of at the end of the list. And I'll also remove a value. So here we can see that at first the size of the list was 0, and then after adding 4 elements, 1, 2, 3, and 4, the string 5 was inserted at index 3, and then I removed the string 2. So we're left with 1, 3, 5, and 4, since 2 was removed here in the second position. The index of 1 is 0, since it's the first element, and the size at the end of all that is now 4. Now going to hashmaps, hashmaps use generics just like ArrayList, but instead of a list, it's a hash table. That means that entries are stored as key value pairs. We can nominate the object types that will be used as the hash map's keys and values. Create a new file called Hashmap Demo. Hashmap is also part of the java.util package. So here I can specify what type the key will be and what type the value will be. Just like ArrayList, this type has to be an object. So I could do string keys and also string values. And to put values in this hash map, we use the put method. Since the keys are strings and the values are also strings, we just put two strings here. And to get the value stored in the hash map, we just need to use the get method and provide the key that matches the value. So for example, if you want to get the string 2, we need to put the key B. So here is the value 2. But let's look at a more complex example. We can also use objects as either the key or the value. Usually we would use them as the value. So what I'll do is I'll create my own custom class here. Let's just call it person, with properties first name and last name. With the single method getName. Now instead of a string value, I'll do person values. Let's call this map people. So let's put some values into this map. Just ignore this first name and last name here. It's just visual cues from VS Code. So I can get a specific entry from this hash map by providing the key, which is one of these three. And then since this will return an object, a person object, I can call the getName method on it. Here it is, John Smith. I can get the entire key set, MT, JS, and JW. And you can use this for loops if you want to loop through all of the entries in a hash map. So here are the three names. We don't always get them in the same order that we put them in the hash map. It's not like a sequential list. We can use the size method to get the size of the hash map. We can use isEmpty to check if it's an empty map. We can use contains key to check if it contains a specific key. And we can use contains value to check if it contains a specific value instead of a key. So it's size 3, it's not empty. It contains the key MT, but not value mark with a C. You can also remove an element either by providing a key or the key and the object value. So let's remove JW and print the list. After removal, there are only 2 more elements in the list. So those are just some of the useful commands for HashMap and ArrayList. If you want the full set of available methods, you can always consult the Java API. ArrayList and HashMaps are great uses of generics in Java, since the concept of lists, maps, and their dynamic methods like add or remove are useful no matter what object type we populate our lists or maps with.